right, hi everybody. So 2.3 is on a couple of other tools that we'll be able to use to find the derivative of different kinds of functions. So we have the power rule right now, which we learned what just made finding the derivative so much easier. So we're going to add on to that with the product and quotient rule. So the product rule is allows us to find the derivative of a function that's two other functions that are actually being multiplied together. And that product rule is pretty simple. I would put a little bubble around this if you feel like you need to reference it. But basically, it's just the derivative of the product of two functions is just the original first function times the derivative of the second plus the derivative of the first times the original second function. So there's a lot of different ways you could write that or think about it. But I'm just going to jump right into some examples so you guys can get some experience with this. So in number one, we see this function where we've got the product of x squared plus 1 times x cubed plus 3. So the derivative of this we can't find just with the power rule unless we multiplied this out and formed a polynomial function. But we don't have, that's an option, but we don't have to do that. So now that we have the product rule, we can apply that. So the product rule tells us that the derivative of the product of those two functions is the original function f of x. So we'll call this one f and this one g just for reference. So the original first function, so f prime is going to be the original first function, x squared plus 1 times the derivative of g, the second function, which if we are looking at right here, we're just taking the derivative of that. That's just 3x squared plus 0. So that would be times 3x squared plus, and then it's the derivative of the first function, so that would just be the derivative of this, which is 2x, times the original g of x, or second function, so x cubed plus 3. Okay, so we've applied the product rule. We have the derivative here. Now it's just a matter of simplifying. So this first set right here, this product, I can actually just distribute 3x squared. So I would get 3x to the fourth plus 3x squared plus, and then likewise here I can distribute the 2x. So that would be plus 2x to the fourth plus 6x. And then as you can see, we can still simplify a little bit. So we end up getting, let me change my color. I've learned that my favorite color on this is purple. So the final derivative is 5x to the fourth plus 3x squared plus 6x. So we found that using the product rule, which does rely on the power rule when we found the derivative of each one, but it just makes finding the derivative of this different type of function possible for us. Okay, but before we move on, I want to show you what would have happened if we didn't have the product rule. So if we didn't have the product rule and we were told to find the derivative of this function, x squared plus 1 times x cubed plus 3, we would have had to have rewritten this by distributing. So I would have had to distribute the first term times the second term. And when we would have done that, we just would have rewritten the entire function to get x to the fifth plus 3x squared. And then I would distribute the 1 plus x cubed plus the 3. And I think that's all I can do. I can rewrite that. So let me order this. Okay, so look what we have. I have expanded this, these two factors into this expanded form by distributing. Now if we apply the power rule, think about what would happen. We would get exactly what we got down here. So that would be 5x to the fourth plus 3x squared plus 6x plus 0. So you've got options here, and either one of these is perfectly fine. So yeah, you don't always have to rely on the product rule. If you think there's a faster way, you could have used, expanded it and done the power rule. All right, so let's look at one or two more. Just a heads up, this is a very long section. It typically takes me 2 or 3 blocks when we're in normal school. I do take my time through it just because these functions get more and more complicated. I'm not going to do every example in here, but I am posting the answer key, so or my notes key, I suppose. So any examples I skip, if you are still confused, I would encourage you to try them on your own, and you can walk through my answers on the notes key. I do want to do number 2. All right, so I'm going to apply the product rule again. So the product rule for the derivative here would be the first function as is, so x to the 4th minus 3, times the derivative of the second. So that would be 6x plus 4, plus the derivative of the first function, so we're just reversing it, flipping it, 4x cubed times the times the original second function, 3x squared plus 4x minus 1. So this is why I mentioned in the very beginning, maybe just put a little bubble around or highlight this up here to remind you to go back up, because it does turn into a lot. It can turn into a lot to keep track of in terms of what you found the derivative of and what you haven't and what you need to. So I would encourage you to do that. Okay, now we just continue. We will multiply and simplify. So these first two right here, I can distribute those. So that's going to be 6x to the 5th, and then 4x to the 4th, minus 18x, minus 12. So that was just distributing this whole thing. If you use area models for that, definitely do that. Just over here off to the side, use area models if you want, or unless you distribute the way I do, it doesn't matter. Okay, and then I just distribute over here. So that's going to be plus 12x to the 5th, plus 16x to the 4th, minus 4x cubed. So all we've done is apply the power rule here, expand here, and now we'll combine like terms, and then we'll be finished with this problem. All right, so I've got 6x to the 5th and 12x to the 5th. So I've got 18x to the 5th. I have, those are gone, 4x to the 4th and 16x to the 4th, so 20x to the 4th. Negative 4x cubed, negative 18x, minus 12. All right, so that's it. It's a long one, but that's as simple as we can get it. Another thing we could have done on number 2 is you could have distributed these first two terms through the second term. You would have had a nice long polynomial, and then you could have just used the good old power rule to get to this final answer. Number 3, I'm going to skip over. This function, to apply the power rule or the product rule, you would just need to rewrite like this: 2x squared minus 1 times 2x squared minus 1. There is another strategy for this called the chain rule, which I know you guys would also enjoy doing, but we definitely won't have time for it in this video. I don't know if we'll have another video coming out or not, but this one we have different strategies right now, just expanding it and then using product or power rule. All right, let's jump down to number 4 and do one with a trig function. So again, the same thing applies. This is 2 separate functions. We've got the function x by itself times the sine function. So this one, while it looks pretty simple, it does require using the product rule. So the derivative of this would be the first function as is times the derivative of the second function. So the derivative of sine, hopefully you remember, is cosine, plus the derivative of the first function, and the derivative of x is just 1, times the original second function. And then I'll just clean it up a little bit here. So that's just x cosine of x plus sine of x, and that's it. So we just applied the power rule here and ended up with this derivative. All right, let's do a couple on the next page. All right, so here, let's make things a little more complicated. Now we're going to look at some functions with roots. So we have two separate functions here. We've got square root of x, and then the second function is cube root x minus 2. Just like when we learned the power rule, the very first step is to rewrite this function using powers of x instead of roots of x. So meaning instead of square root x, I would write x to the 1/2 times x to the 1/3 minus 2, because now we can apply the power rule in the process of using product rule. All right, so applying the product rule here, the derivative of f would be the first function, x to the 1/2, times the derivative of the second function. So that would be pull the 1/3 down in front, 1/3 x, and then subtract 1 from 1/3, you get negative 2/3. Minus 2, the derivative of that is 0, so this is just the first piece of the derivative. So I know it gets overwhelming here, so I have the original function times the derivative of the second function. And then going back to my formula, we add that to the derivative of the first function, which would be 1/2 x to the negative 1/2 times the entire second function, which is x to the 1/3 minus 2. This is the point where I start seeing people's eyes glaze over in class. So we have lots of exponents, fractions, and some of them are negative. So it can be overwhelming, but there is a strategy that will make this doable, I promise. Okay, so the next step here is to multiply where we need to. So here I just have x to the 1/2 times 1/3 x to the negative 2/3. For these, I'm just taking, when you have a base to a power times that same base to a power, remember we just add those two powers together. So the next step here is that. So this 1/3 is my coefficient that just stays out front, x to the 1/2 minus 2/3. So if you have some extra space, 1/2 minus 2/3. So we're going to think of 1/2 as 3/6 and multiply this by 2/2, and we think of this as 4/6. So my new power of x is negative 1/6. Okay. Now I'm moving on to right here. So what we've got here is 1/2 x to the negative 1/2. And I need to distribute that to both of these terms. So I'm going to switch colors because just to keep track of everything here. I'm going to take this whole first thing, distribute it to x to the 1/3. And what happens is we'll get the positive 1/2. The coefficient of 1/2 just stays there. And then I have x to the power of negative 1/2 plus 1/3. Same thing, we're adding these together. You guys are going to get pretty comfortable adding basic fractions together. Again, I need a denominator of 6. So this is going to actually be negative 3/6 plus 2/6, and that gets me negative 1/6 again. Okay. And then I distribute to the negative 2 as well. That's convenient because this 1/2 and the negative 2, when they multiply together, they just equal negative 1. And then negative 1, and then I just keep this x to the negative 1/2. Whoops. Okay, it's looking a little better. 1/3 x to the negative 1/6 plus 1/2 x to the negative 1/6. Same power with the same base means these two terms are like terms and we can add them together. So here we are again taking 1/3 plus 1/2, and we can combine that together. So 1/3 plus 1/2, that would be 2, 6 plus 3, 6. So that ends up being 5 over 6 x to the negative 1/2. And then this whole thing minus, whoops, not 1/2, that's to the negative 1/6. Minus x to the negative 1/2. Okay, this is as simple as we can get in terms of distributing, combining like terms. However, our final answer should not have any negative exponents in it. So all we have to do is convert these to fractions. So let's see, our final answer, f prime, this fraction turns into, or this first term turns into 5 over 6x to the positive 1/6 minus 1 over x to the positive 1/2 or square root of x, either way. This is completely fine. You can leave it like that, meaning you can have these fractional exponents. You could have rewritten this as the 6th root of x and the square root of x. It doesn't matter. This is far enough. All right, let's take another look at one involving trig functions. So in number 6, before you guys jump into these problems, you just kind of need to take a step back and look at what you're dealing with. So in number 6, we have 2x times the cosine of x. So that's two separate functions minus 2 sine of x. So here it's the functions of x that are multiplied together that we'll need to apply the product rule to. So the first piece of this is one function times a second function. However, this negative 2 sine of x, this is not something we need to apply the power rule or the product rule to, because there's no function of x with this negative 2. That's just the coefficient of this function. So the negative 2 is just along for the ride when we take the derivative of sine of x. So there's two parts here. We need to apply the product rule here, and then we'll just take the normal derivative of negative 2 sine of x. So y prime, the derivative, would be, so taking this first piece here, I'll do this first piece. That would be the original first function, 2x, times the derivative of the second function. So remember, the derivative of cosine x is negative sine of x. I'm not subtracting sine of x here. I'm multiplying it by the negative sine of x. And then I add that to the derivative of the first function, which would just be 2, times the original second function, which is cosine of x. Then, so I've taken the derivative of this first piece, then I take the derivative of the second piece, which would just be negative 2 cosine of x. So that's what I've done. I applied product rule here, and then just took the derivative of this piece here. This one, however, we see this negative 2 or positive 2 cosine of x minus 2 cosine of x, so those are gone. And the derivative ends up just being negative 2x times sine of x. So I just pulled this negative out front here to the first part of that, and we're done with that one. Okay, I actually want to add in an extra example that's not included in the notes. So I'm going to do that over here, bonus example, just one more example involving the product rule. All right, so let's say you've got a function called f of x, and it's x squared minus x times the cosine of x. All right, so with this function, we have two pieces of it. We've got x squared minus, and then this term here, which is the product of two separate functions of x. So we have x itself times cosine of x. So this we definitely need to apply the product rule. However, when we do that, so let's get the derivative here, f prime. So this first term here, we just apply the power rule, and then we can move on to the next piece where we need to apply the product rule. But because I'm subtracting, this product rule, when we apply it, will be applied to the whole next set of terms that are a result of the product rule. So parentheses are really important here. So now I will apply the product rule. And you've probably picked up by now with product rule, because you take the derivative of one function times the other and then add that to the reverse of it. Order doesn't really matter, and I wanted to make sure I mentioned that. But so the first function times the derivative of the second function. So the first function, x, times derivative of cosine, which is negative sine of x. I'm just going to put that negative out front right here. Sine of x plus the derivative of the first function, which is just 1, times the second function, which is cosine of x. So I wanted to throw this example in here so that you saw I'm applying product rule here after a minus. So I have to put that whole thing in parentheses, and then the final step would be distributing that. So I would distribute this negative to the negative x sine of x, so it ends up being 2x plus x sine of x minus cosine of x, and that's the derivative. So I actually decided I'm going to stop here and do a few shorter videos. So this video is solely for product rule. We'll get another video for quotient rule, and then finally a video for chain rule. So we will end here.